Hello students, welcome back again to Science Capsule, a perfect self-learning tool. So far we have completed episode 1 and episode 2, most important topics in chapter metals and non-metals. Moving further, in today's episode we are going to learn the third episode, how metals and non-metals react, one of the most important topic as far as examination is concerned. And if you have not watched the previous 2 episodes, you will find it in the I button, and I will also provide in the description. A playlist has been made. You can watch all the 4 episodes to learn this chapter completely. So this video is going to be very important. So watch till the end of this video. If not, subscribe this channel right now and press bell icon for notification. So let us start today's episode. As per the reaction between the metals and non-metals are concerned, it's very important to know some of the basic things. Once it is cleared, then it's super easy to understand the concept. So before that, you should know what is the stable configuration, what is the valence shell, all those things need to be understood. Dear students, let us understand the concept of a stable configuration, valence shell electrons, and how the electronic configuration can be used to identify stability of an element, all those things. So for that I have taken 3 elements with their electronic configuration. So here it is the electronic configuration of helium. Secondly, I have taken for neon. Third one is for argon. So this is the electronic configuration where you will find in case of helium, 1 shell with 2 electrons in its outermost shell, and neon here 2 shells with 8 electrons in its outermost shell. So the shell which is present at the outermost layer, we call it as outermost shell, or we also call it as valence shell. So in case of helium, K shell is the valence shell, and in case of neon, L shell is the valence shell, and in case of argon, KLM. So M shell is the valence shell. Got it? So now you have the idea of what is the valence shell. The electrons present in the valence shell is known as valence shell electron. In helium there are 2 valence electrons. In case of neon we have got 8 electrons in its valence shell, and in argon also we find 8 electrons in its valence shell. All these elements have stable configuration. Now let us understand what is a stable configuration. An element is said to be stable if its outermost shell is completely filled by electrons, which means helium, only 1 shell, maximum electron that can be accommodated in K shell will be 2, so that 2 electrons helium atom acquires. So helium atom has completely filled valence shell. Here valence shell is the K shell. In case of neon, you see the outermost shell is L shell, and it can have maximum of 8 electrons, and neon has 8 electrons. So neon has got stable configuration. And in argon, you see it has got 3 shells, and the third shell has got 8 electrons. And then the 9th standard you must have studied that if it is the outermost shell, then it cannot accommodate more than 8 electrons. So here 8 electrons are there. So argon also has got a complete octet, which means the outermost shell is completely filled by electrons. So in all the electronic configurations you can see very well that the outermost shell is completely filled by electrons. Such an electronic configuration is called stable configuration, and the elements having stable configuration do not show any chemical reactivity, which means they do not react with any other elements since they are highly stable. I hope you understood the concept of a stable configuration, right? Now if you see the metals, all the metals will have 1, 2 or 3 electrons in its outermost shell. Let us take some of the example. Sodium is one of the element, aluminum is one of the element metal. If you see the electronic configuration of sodium, it has 1 electron in its valence shell. If you see magnesium, it has 2 electrons in its outermost shell. If you take aluminum, you see 3 electrons in its outermost shell. So altogether, if you see, all the metals will have 1, 2 or
3 electrons in its outermost shell. Contrary to this, if you see the electronic configuration of non-metals, then it will have 5, 6, 7 electrons in its outermost shell. Take example, oxygen. If you see the electronic configuration of oxygen, the outermost shell has 6 electrons. If you see nitrogen, the electronic configuration, the outermost shell has 5 electrons. If you see the electronic configuration of fluorine, it has 7 electrons in its electronic configuration. So nitrogen has 5 electrons, oxygen has 6 electrons, fluorine has 7 electrons in its outermost shell. So you have to understand this concept that all the metals will have 1, 2 or 3 electrons in its outermost shell can be put on this side. All the non-metals will have 5, 6 or 7 electrons on its outermost shell. We can put all these non-metals over here and connect the stable configuration. We know that the elements which have 1, 2, 3 electrons in its outermost shell get stable configuration by losing, because losing 1 electron, 2 electron or 3 electron is super easy. So we can say that all the metals get stable configuration by losing electrons, whereas in case of non-metals we are very much familiar that it has got 5, 6 or 7 electrons in its outermost shell. So in order to get stable configuration, these non-metals gain 1, 2 or 3 electrons to get stable configuration. Here metals lose 1, 2 or 3 electrons and the lost electrons are gained by the non-metals. In this way, a relationship has been established between metals and non-metals. So this is how metals react with the non-metals. Let us understand by taking some of the examples, and by electron dot structure let us understand how the reaction between metals and non-metals take place in detail.
Students, let us understand how a metal reacts with the non-metal. For that, first I am taking here magnesium as one of the metal, and the non-metal I am taking oxygen. The electronic configuration we have to find out. For that we know that its atomic number is important. So atomic number of magnesium is 12. So the electronic configuration would be 282. And in case of oxygen, atomic number is 8. So 2, 6. So from the electronic configuration, oxygen has got 6 valence electrons, magnesium has 2 valence electrons. And the reaction between the metals and the non-metals can be visualized in terms of electron dot structure. So let us understand in detail. Firstly, what we have to do is always keep in mind that metal should be written first and afterwards non-metal. So here I have written metal on the left hand side, on the right hand side the non-metal, and after that the valence electrons are to be written over the symbol. So here we have got 2 valence electrons in magnesium, so I am mentioning this 2 electrons by putting dot symbol. In order to differentiate it, the valence electrons of oxygen is marked with cross symbol. So here 6 electrons are there, 2, 4, 5, 6. Oxygen has 6 electrons in its outermost shell. If it gains 2 electrons, then the octet will be completed, so oxygen will be stable. Whereas by losing 2 electrons, you see here, by losing 2 electrons the inner shell has 8 electrons, so magnesium will also get a stable configuration. The idea is that magnesium needs to lose 2 electrons, oxygen needs 2 electrons for its stable configuration. So here what happens, magnesium loses 2 electrons to oxygen, and on the product side we can write it as magnesium. We know that by losing 1 electron, 1 positive charge a metal will have. By losing 2 electrons, magnesium will get 2 positive charges, right? No electrons, so this we put in the parenthesis. The second one we will put in the square bracket, and here we write oxygen. Then the electrons should be mentioned. So oxygen has 6 of its own electrons, and 2 electrons are obtained from magnesium, which is in a dotted structure. Got it? So by gaining 2 electrons, we know that non-metal will get 2 negative charges. Here you can see that by losing 2 electrons, 2 positive charges over magnesium, and by gaining 2 electrons, 2 negative charges over oxygen, so a relationship has been established between magnesium and oxygen, we call it as ionic bond. Got it? And the compound so formed can be represented as MgO, and it is the ionic compound. Got it? Let us take another example for better understanding. So in this example, I am going to take sodium as metal and oxygen as non-metal. Now you see the atomic number of sodium is 11, so its electronic configuration would be 2, 8, 1, and oxygen, we know that its atomic number is 8, its electronic configuration would be 2, 6. Got it? So firstly we have to write the electron dot structure for sodium. So we write the symbol of sodium. Its valence electron is 1, and in case of oxygen we have 6. So here I put dot to represent the valence electron of sodium, and here I have to draw the electron dot structure of oxygen. Here I am drawing the symbol of oxygen, and it has got 6 electrons, and mark it with the cross symbol. So 6 electrons, so I have marked with the cross symbol. You see here oxygen needs 2 electrons for its stable configuration. Here if sodium loses 1 electron, sodium gets a stable configuration, but still oxygen remains unstable, right? So in order to make oxygen stable, what we have to do is we have to introduce here one more sodium. Here from the electron dot structure it is clear that oxygen needs 2 electrons, whereas each sodium can lose only 1 electron. So we have to introduce 2 sodium so that 2 electrons can be donated to oxygen, so that both the sodium and oxygen will get stable configurations. So each sodium loses 1 electron, so altogether 2 electrons are being lost to oxygen, and oxygen accepted 2 electrons. So here we have to write the product as first thing comes first. So sodium is the first one. So each sodium loses 1 electron, thereby forming 1 positive charge, which we have to mention within the parenthesis. No electron is left, so here no need to mark anything, and the 2 sodium atoms separately we have taken. So under the subscript we have to mention 2, and the second part, that is non-metallic part, we will mention in the square bracket, and here put oxygen, and whatever the things you see, all those things you write it. Here you see 6 of its valence electron, you have to write 6 valence electrons, and oxygen gains 2 electrons from 2 different sodium atoms. So altogether oxygen, each oxygen atom, only one oxygen atom is there. This oxygen atom accepted 2 electrons, 1 electron from each sodium atom. So altogether we can say that oxygen has gained 2 electrons. So 2 negative charges we have to mention, and we have to close this. So this is how the relationship is established by transfer of electrons between sodium metal and oxygen non-metal, and the compound so formed can be visualized as sodium 2, that is under subscript we have to put 2, and O, Na2O, and this compound is called ionic compound. So this is how we can understand the reaction between a metal and a non-metal by means of electron dot structure. Dear students, practice more and more examples so that you will have enough grip on how to form a compound between metals and the non-metals. If you have any doubt, then you can mention it under the comment section.
So we have learned that the compound formed by transfer of electron is ionic compounds or electrovalent compounds. What are the various properties of ionic compounds? As far as examination is concerned, various questions on this topic will be asked. So let us concentrate on all these properties.
When we talk about the physical nature, ionic compounds are solid in nature and somewhat hard. Solid and hard. This is because, take some example. Here you see sodium chloride Na plus Cl minus, sodium chloride, magnesium oxide Mg2 plus O2 minus. Likewise various other examples here, Mg2 plus Cl2 minus, right? Here in each of the ionic compound you can see that metals and non-metals exist in the form of ions. We can find in each of the compound interionic species. Due to the strong interionic force of attraction held between the metals and non-metals, they attract each other very firmly. That is why they exist in solid and bit hard. More and more energy is generally required to break the bond exist between a metal and a non-metal. That is why ionic compounds are solid and bit hard. The second property of ionic compound is their melting and boiling points. When we talk about their melting and boiling points. Dear students, we know that melting point is the temperature at which a solid changes into liquid, and the boiling point is the temperature at which a liquid changes into gaseous state. Generally, the melting and boiling point of ionic compounds are high. This is because more and more energy is required to break the bond exist between oppositely charged particles. Say for example, Na plus Cl minus, these are oppositely charged particles. In order to break this bond, so once the bond is breaked, then only the constituent particles will go apart. So more amount of heat energy is required to break the bond due to interionic force of attraction. That is why it is seen that ionic compounds have high melting and boiling point. The third property of ionic compounds is solubility. Dear students, ionic compounds are generally soluble in water, but insoluble in solvents such as kerosene, petrol, etc. Fourth and most important property of ionic compounds is conduction of electricity. Dear students, ionic compounds conduct electricity only in molten state. Molten state means liquid state. They do not conduct electricity in solid state. Ionic compounds in solid state do not conduct electricity because movement of ions in the solid state is not possible. You see here Na plus Cl minus, due to the presence of strong interionic force of attraction, the particles get attracted towards each other and they form a rigid structure. Due to this rigidity, the ions are not free enough to move from one place to another. So they do not conduct electricity in solid state. Whereas in molten state, what happens, the electrostatic forces of attraction between the oppositely charged ions are overcome due to heat. Thus the ions move freely and conduct electricity when they are in molten state or they are dissolved in water. So these are some of the most important properties of ionic compounds.
So dear students, I believe you found this episode useful. If so, hit the like button and share as much as possible to your friends. And if you have not subscribed this channel, subscribe this channel right now by clicking on subscribe button and press bell icon so that you won't miss any of my future uploads. So that's all we have in today's video. See you all on another episode number 4, where we will be seeing about the extraction of metals and many more important concepts. Till then, take good care of yourself. Bye bye.